Hey everyone, how are we doing? Are we good? Sorry, I sound awful because I think my boss gave me a cold. I went to the office yesterday. He said he wasn't feeling great, and I'm pretty sure I got a cold off him. Yeah, Lara, we have started. How is everyone doing? Can you hear me? Got a nice mug of warm tea. Don't normally drink tea. I know how to do a poll. I just wanted to try and do a poll from OBS, which is the software that I'm using. So I have found a way, actually. Marianne, greetings. How is everyone doing? Are we good? Put some pluses in the chat if we are well. I don't know if we're... We'll see. Izan, how's it going? How are you? I love how Izan always does the opposite. When I say plus, he puts minus. Outrageous. Cool. Let's get started. Just a big shout out, by the way. Hi, to everyone who's been doing their homework. So well done, keep up the good work. So today we're going to be looking at operations. I don't mean cutting it up. Well, in a way, we are cutting it up, really. We're looking at operations with fractions. And what that means is plus, minus, multiplying, and dividing, okay? If we get time, we'll look at percentages and decimals. If we don't, what I'll do is I'll make an extra video, okay? So no dramas today. We're just going to go nice and steady, okay? So let's get cracking. Everyone, you learn fractions in year 2, well, you are going to be smashing this lesson. So we're just going to go nice and slowly in today's lesson. If it feels like I'm going too quickly, just let me know. But do it. Don't just say you're going too fast for the sake of saying it. Think about it. If it feels like I'm going too fast or you don't understand something, say specifically what you don't understand, okay? And I'll backtrack. So, adding fractions. Adding fractions people normally don't like, okay? So adding fractions are actually quite simple when the denominators are the same. Now, what do I mean by the word denominator there? When we're looking at a fraction, is that the number at the top or is that the number at the bottom? Fire away in the chat. What is the denominator, the top number or the bottom number? All kissing, all bottom, nice. Yep, this is the number at the bottom. Well done, guys. Fantastic start to the lesson. Okay, really, really good. So then we have a question. Can we find, you recap today in school, fantastic. Can we find 1/8 plus 3/8? Simplify your answer and use the diagram for support. Okay, so we've got a circle here. This is our whole. If you do chemistry, why do you teach us maths? Because I do both, Izan. Right, so here is a whole and it's split into 8 pieces. 1, 2, 3, 4, 5, 6, 7, and 8. So what we're going to do is we'll shade 1/8 in. We'll do that green. And then let's do 3/8 in purple. By the way, Izan, do you have a brother in year 13? So there we have 3/8. Okay, so how many 8s do we have in total shaded? 1, 2, 3, 4. So we've got 4 out of the 8 parts shaded. And can we simplify that? Lara, yeah, well done. Guys, if you get the answer, help each other out. We're a community, okay? So how can we simplify this? What can I do to the top and the bottom numbers? What can I divide them by? What number goes into those? I can divide the top by 4 and the bottom by 4 to give me what? So 4 goes into 4 once, 4 goes into 8 twice, 1/2. Happy days, well done. Yeah, it says to simplify, so if it says to simplify, we express it in its simplest terms, okay? So well done. So these are what? What type of fractions are these? Where they're the same. We looked at this last week. We didn't call them equal fractions, but similar. We call these equivalent fractions. Sude, I will take that. Absolutely, well done, Pre. Jane plays. Good stuff, everyone. Yamal, I will give you that. Right, let's move on. So, things get a little bit more tricky, okay? Things get a little bit more tricky if the denominator's equivalent, but how do you simplify it again? So what we do is we look at our multiplication table. So what number goes into 4 and 8? What is the biggest number that goes into 4 and 8? Just curious, Izan. Because I saw the same name when I was looking at one of Neil's lessons. Yeah, 4. So 4 goes into 4 once, and 4 goes into 8 twice, so we can simplify that to 1/2. Okay, so let's have a look when the denominators are different. So if we were trying to add 1/2 and 1/4, how could we do this? What can we do here? No worry, Jane Plays. So look, here is my whole and it's split up into halves. But what could I do to this? So my plan is to try and get this into quarters. Make this into quarters. What could I do to my diagram to help me see this visually? Ooh. Yeah, you're telling me the answer, Vihan. Tell me what to do to my diagram. What could I draw? If I was going to draw a line, tell me how to draw the line. Halve it. Okay, nice. I like it. Okay, so what we're going to do is we're going to draw a line and we're going to split it up into 4s, okay? So if we split it up into 4s, my half is now represented as what? How many quarters is my half? My half is represented as 2 quarters, okay? So let's write this down together in our workbook. So 1/2 is represented as 2 quarters. So what I did was, what did I multiply the top by? I multiplied the top by 2 and the bottom by 2 as well. Lovely stuff. Good work, guys. Okay, and then I still have to add on an extra quarter, and I'll do that in a different color. So let's do that in this pastel blue. No worries for being late. So here is my quarter that I'm adding on. Now, if I add these two guys up, what do I actually get? Mr. Goody Two Shoes. He's the moderator. He has to be. Okay, so now the denominators are exactly the same. Okay, so now the denominators are the same. So what we can do when the denominators are the same, the denominator stays as 4. We can simply add up the numerators. So this becomes 2 plus 1. So we have 3 quarters. You can see that there's 1/4, 2/4, and 3/4. Okay, shaded in. Before we move on, do we see why we have to make the denominators the same when we're adding fractions? Can you put a big fat plus in the chat? Jane Plays, yeah, tell me which bit you don't understand. Izan, we'll go through the kiss and smile method in just a second, okay? We'll go through the kiss and smile method in just a second. Maybe Edward or the community can help Jane Plays out. Like the X and adding part. Okay, cool. So, we'll just recap this again, okay? No worries at all. Do you see why I split this into half? First of all. So, I'll redo it, okay? So, here is our half. So, we had a whole circle. So, here is 1/2. Here is another half. But we can't add 1/2 and 1/4 quite easily, okay? Because this denominator is different to this denominator, okay? So it feels quite tricky when you're trying to add two fractions with different denominators. So what I can do is I can turn these halves into quarters. So that's what I want to do. So to make this into quarters, I draw another line horizontally, okay? So here I've got 1/4, another quarter, another quarter, and another quarter. So I've got 4 quarters, okay? So do you see what I'm doing here? Let me know in the chat if that makes sense. So this half, here it is, this half has now been converted into what? 2 quarters, which is the same as 1/2. Agreed? So this now becomes 2/4. And then I need to add this extra 1/4 on. So how many quarters do I have in total now? Now that my denominators are the same, I just look and add them up. 1, 2, and 3. Okay? So 1/4 plus 2/4 gives me 3 quarters. So when my denominators are the same, to add these fractions up, I just simply leave the denominator as a 4 and just add up the numerators. So this becomes 3/4. Jane Plays, all good? Okay. Lovely jubbly. Great, and that was a really good example of saying where you didn't understand something. So that was really useful for me as the teacher as well, okay? So, good stuff. Now, we are going to do shed loads of practice, and I want lots of audience participation. No worries, HB, that is all good, okay? So it doesn't matter where we get to in the booklet. We're not going to try and race to finish it. What we need to do is just drill in the skills that we're learning in today's lesson, okay? So let's rewrite question A, because we need to add up 2 over 5 and 1 over 10. Now, can I just add these fractions up as written? Can I add them up? Yes or no? Tell me in the chat. Justify your answer as well. Okay, Samira's saying no, Jane plays, Marianne saying no, MD, no. Okay, lots of no's. Okay, fantastic. Lots of no's, fantastic. Okay, good. What do I need to do? I need to make the denominators the same. When we're making the denominators the same, we are finding a common denominator, okay? That is what we need to do. So we need to think about multiplication tables for each denominator, okay? So let's look at our multiplication tables. So here, for this denominator where it's over 5, it's a 5 times table. 5, 10, 15, 20. And then for this denominator, which is over 10, this is the 10 times table. So we are looking for our lowest common multiple, okay? So when we're finding a common denominator, we are looking for the lowest common multiple, a number that is a multiple of both of these denominators, okay? So which number is that? Based on my multiplication tables, what is my common denominator here? Absolutely, Priya, is 10. Superb. Excellent, excellent, excellent. Good stuff. So what can we do to this number to get it as a 10? You have to times the fraction. Okay, good. So what do we multiply this by to get it as a 10? Yeah, if we times this by 2, that becomes a 10. Whatever we do to the bottom, we have to do to the top as well. So we times the bottom by 2, we have to multiply the top by 2 as well. So now, what does this become? So this becomes 4 over 10 plus 1 over 10. And now my job is really easy. So what do I do now? I've got the common denominator of 10. So my answer is going to be something over 10. I just add up the numerators. So 4 plus 1 equals 5 over 10, which is equal to 1/2. Lovely. Because I can simplify this and express it as 1 over 2 because 5 goes into 5 once and 5 goes into 10 twice. And the job is done. Can you let me know if that makes sense for number 1? Can we put a plus or a minus? I know Izan's going to put a minus. Hey, Vibrant Vanessa, how are we doing? Is that a yay or a nay? How are we feeling about this? I get it, Izan. Nice. Cool. Edward is a moderator and he is helping out with questions and to make sure that people just don't spam, okay? Right. Okay, no worries, Mr. Nfour. We will have a look at question B. Okay? Lovely jubbly, Mr. Punjabi. Okay. Let's have a look at 3 over 8 minus 5 over 24. Now, remember, because I fully understand this, fantastic. Okay, now remember, subtraction is just the opposite operation of addition, or it's the opposite of addition. So what we're going to do here is the same thing, but we've got a problem. These guys are not the same. We don't have a common denominator. We've got something divided by 8 here and something divided by 24. So let's write down the 8 times table first. 8, 16, 24. So we're looking at the 8 times table here because we're trying to find a lowest common multiple. Nesta's got it. And then let's look at the 24 times table. 24, 48. Now, which number is a common multiple here? What can I say? Do we have a common factor? Let's have a look. Can we say that 24 is our lowest common denominator? We do, Celia. Have a look. So look, in the 8 times table, 8 goes into 24 3 times, 24 goes into 24 once. So our common denominator here is 24. Thank you, Izan. Really, really good. So now what I'm thinking, what number do I need to multiply 8 by to get to 24? So 8 times some number gets me to 24. Have a look at this. Not 8 times 1, but 8 times 3. Absolutely, good stuff. So I multiply that by 3. So whatever I do to the denominator, I do to the numerator as well. And now we're in business. So have a look. So my numerator now becomes 9, and my denominator becomes 24, and I'm taking away 5 over 24. Okay, so what do I do here? Yes, Edward can put you in timeout, and I can put you in timeout as well. So the denominator now becomes 24 because we leave it because the denominators are the same. And then we just do 9 take away 5, which is what? Do we all agree that's 4 over 24? And then we can simplify this. How can we simplify this? What can we say? What number goes into both 4 and 24? Do we all agree it's 4? So this is where your 4 times table comes in handy. So 4 goes into 4 once. Yeah, really good, Rickson. Nice. Izan's got it as well. Marianne, Pri, Mero, Lara, fantastic. 4 goes into 24 6 times. So in its simplest terms, my answer is 1 over 6. Okay, how do we feel about B? Happy face or sad face? Let me know in the chat, please, guys. How are we feeling? Jay's got it as well. Shiraz, yeah, absolutely. We've got 3 more examples to do. Okay, we've got 3 more examples to do. The problem solving is confusing on B. Okay, cool. What we're going to do is, let's have a look. So I guess the trick here is we have to find a common denominator, okay? So let's have a look. Let's have a look at C, okay? Now, help me, I'm trying to, the Noir-Fours. Right, so let's have a look at C. So we've got 2 over 7 plus 2 over 5. Now, when we're looking at high order, right, are our denominators the same or are they different? Please focus. No worries, you've got no space. You can do it on the opposite page. They're different, okay? So let's have a look at our multiplication tables. So let's have a look at our 7 times table. 7, 14, 21, 28. What comes next? 35, okay? So we are looking for a common factor, okay? We are looking for a common factor between these 2 numbers, okay? So a number that goes into both 7 and 5, okay? So and there isn't a common factor here, okay? So there's no common factor here. So this is a bit harder. So what do we have to do is, let's have a look at our 5 times table. So 5, 10, 15, 20, 25, 30, 35. Okay, what could I do here then? What could I do here? So I can multiply the 7 by some number, because look, 35 appears in the 7 times table and 35 appears in the 5 times table. Yeah, if there's no common factor, we have to multiply them together, okay? Not going to do the kiss and smile method just yet. So to get to 35, what do I need to multiply 7 by? Do you all agree it's 5? Oh. So if I multiply that by 5 and if I multiply that by 7, look at what happens. I now have a denominator of something over 35 for both of them, okay? Now, whatever I do to the denominator, I have to do to the numerator as well. So if I multiply the denominator by 5, what do I do to the numerator? I also have to multiply that by 5 on the left one and multiply this one by 7, okay? So this becomes 10 over 35 plus 2 times 7 is 14 plus 14 over 35. Okay, so now what do we do? Now my denominators are common. I'm just going to express this as something over 35, and I can add up 10 and 14. So this becomes 24 over 35. Now, can I simplify that anymore? Can I simplify that? Is there a number that goes into 24 and 35? Nuh-uh. So that's expressed in its simplest terms, okay? Cool. All right. Good stuff. Let's have a look at D. We're not going to get through much of this lesson, I think. So let's have a look at D. Lots of participation, please, guys. So let's have a look at D. So we're doing 5 over 8 minus 5 over 12. Tell me what to do here. We're going to do the kiss and smile method next slide, okay? So we can do that when there's no common factor. So is there a common factor for 8 and 12? Can I just multiply one of these and get the other number? No. So what do I have to do? Let's look at my multiplication tables by looking for a common denominator, okay? Between 8 and 12. So let's have a look at the 8 times table. 8, 16, 24. And let's have a look at the 12 times table. 12 and 24. Okay, so no worries then, of course. Hope it's starting to make sense. What is my common denominator going to be? Can I repeat everything? No. Sorry. Absolutely then, of course. It's 24. Okay, good. So look, 24 is my common denominator here, okay? So I need to multiply this 8 by some number so I get to 24. And this 12 by some number, so I get my denominator as 24. So what am I going to multiply the 8 by to get to 24? 8, 16, 24. So I'm going to multiply this by 3. And I'm going to multiply the 12 by 2. Okay? That's how we get this denominator. Good, Nesta. Nice. But remember, whatever I do to the bottom, I do to the top as well. So 5 times 3 is 15. 5 times 2 is 10. Now my denominators are the same. My answer is going to be something over 24. So this becomes 15. Take away 10. So I just subtract the numerators. So this becomes 5 over 24. And that is expressed in its simplest terms. Stop and restart the lesson, please. Sorry, I can't do that. But what you can do is rewatch it from the beginning if you've joined late, okay? So let's have a look at E. E is the last one. Okay, let's go. How do we know the common factor? Okay, so were you here for the first lesson when we looked at common factors? So if we're having a look at 5 and 10, yeah, okay, if you were here, then you know what's going on. Bordeaux, I don't know what that means, but thank you very much. Right, so in here, there is a lowest common multiple, okay? And the lowest common multiple for this one is 10, okay? I don't understand, Edward, help me. Okay, Mahir, were you here for the beginning? Yes or no? Right, so a multiple is a number that fits into its times tables, okay? So a multiple is a number that fits into its times tables. Now, if there is no common factor, we have to find a common denominator by looking at the multiplication tables of 7 and 5, okay? Now, let's have a look at the first one. Let's have a look at the first one. We'll do A all again. Not a problem at all. Now, the first problem is we can't just add these up because my denominators are different. So what do I have to do? I need to find a common denominator. So I look at my multiplication tables for 5 and 10, the denominators that I have. Okay, so 5, 10, 15, for example. And then let's have a look at the 10 times table. That'd be 10, 20, 30. Is everybody with me so far? Is there a number for the 5 times table and the 10 times table that is common to both? What is that number? For A, it's absolutely 10, agreed? So this one is already 10. So my question here is, how do I make this left-hand fraction 10? What can I multiply 5 by to get to 10? I can multiply that one by 2. And then I can multiply the top one by 2. So whatever operation I do to the bottom one, I have to do to the top as well, okay? So that's what we're doing. We're trying to find a common denominator, okay? So let's have a look at E. Let's have a look at E. So 4 over 9 plus 7 over 20. This is going to be an interesting one. Okay, right. Is there... I understand now. Carry on the lesson, please. You're welcome here. Fantastic. Right, let's have a look at E. Now, is there a common denominator between 9 and 20? I mean, there is. So, what do we think we could do? What could we do? Now, the way to do this is a bit like, no worries, Shiraz, my pleasure. So I can multiply this 9 by 20 and this 20 by 9. And whatever I do to the bottom, I do to the top. So that means this becomes, what's that, 80 over 1, sorry. Yes, 80 over 180 plus 63 over 180. And there you go. Now I can just add these up. And that becomes something over 180. So 80 plus 63 is equal to 143 over 180. And there you go. Lovely jubbly. Okay, let's move on. Then of course, we're not going to do a Kahoot, but thank you very much. You did it correct. Really easy. Fantastic. Okay, now, there is a way to add or subtract fractions that requires less thinking about common multiples, okay? Essentially, the common denominator can be found just by multiplying the denominators together. This way, you always have a number that sits in both the multiplication tables. So let's have a look at this kiss and smile method. Right. So, if we don't really want to worry about common multiples, what we can do, yeah, absolutely, what Edward's saying, actually ask a specific question, okay? Can we do D again? Malar, D is going to make more sense when we do the kiss and smile method, okay? So, what can we do here? Let's have a look. So what we can do is we can start by multiplying these, okay? So we can start by multiplying these together, okay? So we're going to multiply these. You prefer the other method. I prefer the other method as well, Rickson, but let's have a look at this method as well, okay? So let's multiply the 8 and 3, and then what we're going to do is we're going to cross multiply like this, okay? So you can see it's a bit like these guys are kissing and here is a smile, okay? So we are going to rewrite this. So what is 8 times 3? 8, 16, 24. So 3 8s are 24. And then what is 5 times 3? So 5 times 3 is 15. And then 8 times 2 is what? Ah. Okay. So what do we get? Okay, fire away in the chat. What do we get? So what is my denominator going to be? I'll show you what it stands for in just a second, okay? Right. Is it going to be 1 over 24? Check. Have a look. It's actually going to be something over 24. But what's 15 take away 16? What's that? Yes, Izan's got it. So 15 take away 16 is minus 1 over 24. Well done. Yes, nice, MD. Good. Okay. Now, what's happening? I'll show you what's happening. Look, this is a smile. Okay. These guys, when we cross multiply, that looks a bit like a kiss. Okay. So these guys are kissing when we cross multiply. And then at the bottom, we say that is a smile. That's why it's a kiss and smile. Okay. Cool. This way we don't have to worry too much about knowing our multiplication tables and looking for common multiples. Okay. So let's have a look at B. 4 over 7 plus 5 over 9. Let's use the kiss and smile method. If you want to call it another method, that's absolutely fine. It's just a name. Okay. So let's start by multiplying the denominators. When you multiply the denominators, what's 7 times 9? So what's 7 times 9? Yep, absolutely, it is 63. Okay, so now we're going to do 9 times 4. So what's 4 nines? Call it whatever name you want. Ollie, Ollie, yeah, absolutely. This works as well. Yeah, absolutely. So 9 times 4 is 36. Good. And then, what's 7 times 5? 7 times 5 is what? Do we agree that's 35? Okay, good. So now what's 36 plus 35? What are we saying? What's 36 plus 35? Yes, 71. Good. Over 63. Oh, hello. What type of fraction is this? What type of fraction is this? Is it proper or improper? Yes, this is an improper fraction, okay? So this is an improper fraction, where the numerator is larger than the denominator. Very good. Enes Vinagi, Burhan, Javi, really, really good stuff. Okay, and let's finish off with C while we're here, okay? So, we've got 1 over 12 plus 1 over 10. Okay, cool. So let's do the smile bit first. Let's multiply these together. So what's 12 times 10? Do we all agree that's 120? And then 1 times 10 is 10 plus 12 times 1, which is 12. So this becomes 22 over 120. And there you go. What's good about this method and what's bad about this method? Yeah, we can change it into a mixed number if you want. So 63 goes into 71 once, and then what the remainder is, so what's the remainder? 8. 8 over 63, there you go. Right. Yeah, the problem with this is it's a bit longer and you have to simplify. So it takes a bit more time, but use whichever method you prefer, okay? Cool. All right. Okay. Let me know in the chat, do we prefer looking at common multiples, or are we preferring the kiss and smile method? Let me know which method you prefer. Soraya, we're doing fractions today. Rapture, you can always skip backwards, okay? Kiss and smile, lots of kiss and smiles. Okay, good. Let's have a look at mixed number and improper fractions. Okay, cool. So, a bit of recap and revision from last week as well. So, we've got a problem with number, or letter A actually. So we've got 4 3/7 plus 2 over 5. Now, what do we do here? What's the problem? The problem lies with this, because this is expressed as a mixed number. And that's going to make our life harder. But we want to make our life easier, so what can we do to this mixed number? How do we convert a mixed number into an improper fraction? Because that's going to make our life way easier. Oh, 31 over 7. Nice. Okay, good. So, to do that, we do 4 times 7. We do 4 times 7, which is 28. And then add on the 3. So that becomes 31 over 7 plus 2 over 5. Okay, cool. Imposter fraction. Yeah, I like it. Okay. So, we can multiply this one by 7. Oh, this one by 5. And this one by 7. And whatever we do to the denominators to find a common denominator. Fantastic, Jane Plays. Good stuff. So we're going to multiply the numerators by 5 on the left and top numerator by 7 on the right hand side. So what does this become? So what's 31 times 5? 31 times 5 is 155 plus 5 times 7 is 35 ofs, and 2 times 7 is 14. So what's 155 plus 14? That is 169 over 35. Okay, there you go. Absolutely, good stuff. So what can we do? If we want to get this as a mixed number, what could we say here? So how many times does 35 go into 169? 35, 70. Then what? Then what? You can miss the third one. The fourth one's going to be 140. So it's going to be 4 times. And then what? It's going to be 105, right? anyway. And then the remainder is going to be 29, and I keep my denominator the same, which is 35, and Bob is your uncle. There you go. Right, let's have a look at B. So we've got 5 1/2 minus 3 1/4. All right, tell me what to do. NS Vinagi, you can do the kiss and smile method. It's good looking at both methods, okay? So the problem here is we've got two mixed numbers, okay? Yeah, you can do the kiss and smile method with any fraction for sure. Right, so let's convert these mixed numbers into improper fractions. So we're going to multiply that together and then add on the 1. So this is going to become 5 times 2 is 10 plus the 1, which is 11, over 2. Minus, let's convert 3 1/4 into a improper fraction. So 3 4s are 12 plus the 1, which is 13, over 4. Okay, cool. So now what do we do? Do we have a common multiple here? Dawood, yeah, I can. But I'm going as slowly as possible, I think. Right, what can we do here? Is there a common multiple? What is my common multiple here? You sure? Rickson's saying yes. Ashwin's saying yes. It is 4. Absolutely. So my common multiple here is 4. Okay, so what I'm thinking, what do I need to do? What do I need to do to convert this 2 into a 4? Multiply it by 2, obviously. And whatever I do to the denominator, I have to do to the numerator. So this becomes 22. I'll do it the long way and then add them up if you want. So this becomes 22 over 4 minus 13 over 4, which becomes 22 minus 13 over 4, which is equal to 9 over 4. And let's have 9 over 4, please. Let's have 9 over 4, please, as a mixed number. So 4 goes into 9 twice fully with a remainder of 1. And we keep the denominator the same. So this is 2 1/4. And the job is done. Well done. How are we finding it so far? Maybe we haven't done this in school, but are we happy so far? Rickson, check that. It's actually 2 1/4. Cool. Good, really easy. That's great. Fantastic. Great. Tell me how your confidence has changed over the lesson. Were we less confident to start with? Are we feeling more confident towards the lesson at the middle? Hard, easy, no lie. I would say you do you, but thank you. Start to less. Okay. No worries, that's all good. Okay, let's continue. Now, always confident. Okay, whatever method works, that's what you go for. Whatever method works, that's what you go for, okay? A little hard. Okay, it's a little bit challenging. The 11 plus is more of a stretch, okay? Compared to what you're normally used to in Key Stage 2. Right, comparing fractions. In the middle is absolutely fine as well, okay? Shiraz, let's not ask people to block others. Baba 2, okay, thank you very much. Okay. You think everyone just got beginner's luck? Maybe. Right. Comparing fractions. Now, this comes up again and again in 11 plus, okay? So they're going to give you fractions with different denominators, and your job is to work out which one is bigger. Okay, so you have to order them in size. So, if we're comparing 3 over 7 and 2 over 5, which one is bigger? Fire away in the chat, please. Tell me which fraction is bigger, 3 over 7 or 2 over 5? Tell me what to do. Ooh, make both the denominators the same. Sude, well done. Get a prize. So, how do I make both fractions the same? Or the denominators the same? What do I do? Ooh, Fahad's saying 2 over 5. Okay, prove it to me. I'm not just going to accept it. What can I do to both of them? Okay, let's have a look at the 7 times table. Let's have a look at the 7 times table. 7, 14, 21, 28, 35, 5, 10, 15, 20, 25, 30, 35. So, is there a number in the 7 times table and in the 5 times table that is common to both? Yes, and that is 35. Okay, so we have to make the denominators 35. To make this denominator 35, I'm going to multiply that by 5. To make this denominator 35, I'm going to multiply it by 7, okay? But remember, whatever we do to the denominator, we have to do to the numerator as well, okay? So 3 times 5 is 15. 2 times 7 is 14. So now my denominators are the same. I can actively compare the two. Which one is bigger now? Okay, fire away in the chat. So which is bigger? It is absolutely 3 over 7, okay? So these are my equivalent fractions. This is bigger than this. Because 15 over 35 is bigger than 14 over 35. So 3 over 7 is bigger. Okay, that's it. That's all we have to do. Now it's your turn to practice, okay? It's your turn to practice. So, to compare and order fractions, we're going to rewrite each fraction over the same denominator and then compare the numerators. That's all we're going to do. So, fire away in the chat. What is bigger, 4 over 9 or 5 over 11? Tell me what to do, guys. Shiraz, this is the way to do it. That's it. Okay, tell me what to do. Right. How can I make the denominators the same? Tell me what to do. I don't want the answer. So what can I multiply this by and what can I multiply this by so that my denominators are going to be the same? Okay, well if I multiply this by 11 and this by 9, what are my new denominators going to be? Okay, yeah, absolutely. So 9 times 11 is 99. 11 times 9 is 99. Okay, but remember, whatever I do to the denominator, I do to the numerator as well. So what is 4 times 11? That's 44. And 5 times 9 is 45, if I'm not mistaken. So which is bigger? Absolutely, Dilpreet. Good. So do we all agree that this numerator is larger than that numerator? So we can say that 5 over 11 is larger than 4 over 9. And the job is done. Okay, good. All right, nice. Let's have a look at our second task. We have to order these fractions from smallest to largest. Okay, you get it now, you're mild. Okay, good. Now what I'm saying is you might not get it straight away, but we're going to do shed loads of practice, okay? So it will come. You just got to believe. Like Mikel Arteta, trust the process, okay? So let's have a look at all of these fractions. We're going to order them from smallest to largest. Okay. Now, when we're looking at this, what is... Do we have a common multiple here? Do we have a common multiple? Yes or no? I think we do. Fad's saying yes. Do we or don't we? Rickson's saying 24. Yeah, absolutely. Because these numbers all go into 24. So look, 8, 16, 24, 4, 8, 12, 16, 20, 24. That's my 4 times table. My 6 times table, 6, 12, 18, 24. And then my 12 times table, which is 12 and 24. So we can see the common denominator is going to be 24. Yamal, yeah, of course, I hear it all the time. Okay, so what we're going to do is convert all of these to have a denominator by 24. So what do I need to multiply this 8 by to get to 24? So we're going to multiply that by 3. Whatever I do to the denominator, I do to the numerator as well. So this becomes 9 over 24. No worries. Okay. And then 1/4. Now, what are we going to multiply this by to get to 24? So look, 1, 2, 3, 4, 5, 6. I have to multiply that 4 by 6 to get to something over 24. Whatever I do to the bottom, I do to the top. So 1 times 6 is 6. Okay, I am going to multiply the denominator by 4 there and the numerator by 4. So that becomes 4 over 24. And then finally, that's going to be multiplied by 2, and the 5 is going to be multiplied by 2 as well. So that becomes 10 over 24. Okay? Done. Have I done it though? Have I done it? I've converted them all so they've got the common denominator, but there is a problem. I haven't actually ordered them from smallest to largest. So in the chat, what is the smallest? What is the largest? Okay, so the smallest is what? The smallest is clearly 1/6, which is 4 over 24. So I've done that one. What's next? 6 over 24, which is actually a quarter. Okay, done that one. Then 9 over 24, which is 3/8. Done. And then 5/12 is the largest, because that's 10 over 24. Done. No worries, you Miles. It's all good. It's all good. It's not for everyone. If it's not for you, then it's not for you. Okay. Multiplying fractions. Okay. We're probably just going to get to multiplying fractions. We might even have time for a Kahoot today. Okay. Now, imagine we have a chocolate bar. Okay. So we're moving on from adding and subtracting to multiplying. Okay. So if we can get multiplying and dividing fractions done, then we've done a good job. No worries, sorry, that's all good. Maybe you could refresh the stream and go back. So you can always rewind and go at your own pace, okay? So, imagine we have a chocolate bar. What chocolate bar do we have? Tell me in the chat. What chocolate bar do we have? My favorite is probably a Kinder Bueno. Now, let's say this chocolate bar is broken in to 2 equal pieces. So here is my chocolate bar, and I'm breaking it into 2 equal pieces. Okay, now pretend, because you're very caring and sharing, that you want to share your piece with your best mate. Okay, Hershey's, nah, it's too sweet. So you decide to split it in half and give them one of those halves. So here is your half. So this is your half. And you are sharing your half. So if you share your half, this is what you get, and this is what your mate gets. Okay, now let's think about this, okay? Snickers. I haven't had Snickers in ages. Why, Vinay? Because we are caring people and we want to give our chocolate away to our pals so they have something to eat, okay? This is why we're doing it, because we're sharing. Now, think about it like this. When we share half of your already hard chocolate, you're not giving all of it away, right? You're just giving some of it. Now, when we're talking about multiplying fractions, we're talking about sharing part of something, okay? You're not giving it away. Wow. Now, with our chocolate bar, we first took half, okay? So, for example, here is a whole, and we already split it into a half. Once we had our half, we split it into half again, okay? So what this means is we shared half of a half. So if we shared half of a half, what does that equal from our whole? Have a look at this picture. So here is our whole, split into half again. Now what does that represent from our whole? Absolutely, it represents 1/4. So if we have 1/2 of 1/2, okay, so it's a half of a half, this of means to multiply, okay? So when we're multiplying, look what's happening. A half of a half equals 1/4. So can you tell me what we're doing then when we're multiplying a half and a half? What's going on? What are we doing to these guys? We're simply multiplying the numerators and we are multiplying the denominators, okay? That is it. That is it, okay? So let's have a look. And you've got a little guide here. We simply multiply the numerators and the denominators when we are multiplying fractions, okay? No spamming, please. If you can't focus, you can come back to the lesson later on, okay? But don't spoil it for other people, please, because some people do want to learn and listen. So let's have a look at question A. So we've got 2 over 5 multiplied by 4 over 9. Tell me what to do. Your chat disconnected, no worries. So let's have a look at question A. What are we going to do to the numerators? What are we saying? Multiply them, absolutely. So this becomes 2 times 4. Then what are we going to do to the denominators? Do it in a different color. So what are we going to do to these guys? We're going to multiply them as well. So that's 5 times 9. So 2 times 4 is 8. Divided by 5 times 9, which is 45. So my answer here is 8 over 45. Can I express that in a simpler way? No, that's in its simplest terms, okay? Done. Let's have a look at B. 5 over 7 times 3 over 11. Okay, what we're going to do is we're going to multiply these, and we're going to multiply these. So 5 times 3 is 15. 7 times 11 is 77. Done. Can't express that in simpler terms. Sorted. Okay, let's have a look at C. 3 over 4 times 5 over 6. We multiply the numerators and we multiply the denominators. So this becomes 15 over 24. Now, can I express this in a simpler way? Rapture, fantastic. It's so easy. Superb. Right. Can I express this in a simpler way? Which number goes into 15 and 24? Yeah, I can. Because 3 goes into 15 and 3 goes into 24. So 3 goes into 15 5 times. And 3 goes into 24 8 times. So this can be represented as 5 eighths. I can, absolutely. And the job is done. Okay. We're getting there. We've got about 9 minutes left. We're probably going to get to the point I thought we were going to get to, okay? So percentage and decimals will have to wait, okay? Right. Don't make me put people in timeout, please, guys. I take no pleasure from it. So, let's have a look at question A. So, problem here is what? What's the problem here, guys? Now, the problem here is I've got what? I've got mixed numbers. What do I have to do? What can I do? I have to convert these into what? Yes, absolutely. So I need to convert these into improper fractions. Absolutely. So let's convert these into improper fractions. So what is this one going to look like? You'll stop arguing now. Okay. Yeah, absolutely. So this becomes 2 times 3, which is what? 6, plus the 1, which is 7 over 3. Multiplied by, we multiply the 1 and the 5. Add on the 2, so that becomes 7 over 5. So now we just multiply the numerators and the denominators. So 7 sevens are 49. 3 times 5 is 15. 49 over 15. And the job is done. You can leave it as an improper fraction if you want. As part of your revision and work, you should think, can I convert that into a mixed number? If you convert it into a mixed number, I think 15 goes into it 3 times, if I'm not mistaken. So that's 45 with a remainder of 4 over 15. There you go. Okay, let's have a look at B and then we'll move on. We'll move on to dividing, okay? So, let's have a look at this one. So tell me what to do in the chat, please, guys. Okay, what are we going to do here? We need to convert these improper fractions. Sorry, we need to convert these mixed numbers into improper fractions. So, 4 times 7 is 28, plus the 2, which is 30 over 7. We're going to multiply 3 and 4 together, which is 12, plus 3, which is 15. So we're going to add on the 3 over 4. Okay, so now, 15 times 30. Okay, what does this give us? So 15 times 3 gives us 45, and we add on the 0. And then 7 over 4 is 28. Okay, we can leave it like that. Let's leave it like that. Okay, I think it can be simplified further, but we'll leave it like that. Okay, before we move on, are we happy so far? Let me know if we're happy so far. Soraya, stop asking for Kahoot. We're not going to have time today. Cool. Yeah, fantastic. Good stuff. Okay. Right. Dividing fractions. Okay, we're probably just going to finish up on this slide, okay? Cool. Now, when we're dividing fractions, there is a really nice method that we can use. But before we get into the method, if I was to ask you to divide a number, Prissies, I don't know what that means. It's on your mug. That's Belle. What are you talking about? That's from Beauty and the Beast. Right. If I asked you to divide a number by 2, what is another way that I could have asked the same question? So if I was to ask you to divide by 2, how could I write that? I could write that as divide by 2 over which number? Why not, Dilpreet? Yeah, that could be written as 2 over 1, okay? But there is another way that I could have asked the same question, okay? Because dividing by 2 over 1 is the same as what? Is the same as multiplying by? Absolutely, Unique. It is the same as multiplying by 1/2. Good. Okay, now let's think about a little trick to remember this, okay? So, what did we do? We changed sign, okay? Now, there is a way that we can remember this. This is KFC, okay? The kernel. Yeah, absolutely. A half is exactly the same, 0.5. But we're going to write it in fraction form, so 1 over 2. So, K stands for keep the same, okay? So, the first fraction we're going to keep the same. What we're going to do is we're going to flip the second fraction. And then what we're going to do is we're going to change the sign, okay? So let's put this into practice, okay? Go KFC if you're hungry. Yeah, absolutely. So keep, flip, change. So let's have a look at A. So we've got 3/4 divided by 5 over 8. Okay, which one are we going to keep the same? Never heard it? You heard it now. Okay, so we'll keep that the same. So we've done the K bit, okay? So that becomes 3 over 4. We'll leave it as it is. We're going to flip this one, okay? We're going to flip it. So the 8 is going to be where the 5 is, okay? So that becomes 8 over 5. Done. And then we have to change the sign. So this becomes multiply now, okay? All right, so now we're in business. Now we're just multiplying fractions. So 3 times 8 is 24. 4 times 5 is 20. So this is 24 over 20, which becomes 6 over 5. Nice. Sorted. Right, let's have a look at B. Tell me what to do for B. Okay. So 7 over 9 divided by 2 over 3. I'll stop talking about KFC. Okay, so we're going to keep this one the same, so 7 over 9. This one we have to flip, so the 3 and the 2 flip places. And this we're going to change sign. Now we're just multiplying fractions, so 7 times 3 is 21, 9 times 2 is 18, and the job is done. So that is 21 over 18. Okay, can we represent that in another way? Can we represent that in another way? Yes or no? Or are we just going to leave it as 21 over 18, which looks a bit ugly? Okay, well, how many times does 3 go into 21? Okay, how many times does 3 go into 18? 7 over 6. Done. Okay, sorted. Okay, if you want to leave it as a mixed number, 6 goes into 7 once with 1 remainder, so that's 1 and a 6th. Okay, sorted. And we're on time. Okay, we will leave it there. Now, for the remaining slides, which we've got quite a few of, I tell you what I will do. I will make a video making sure that I go through these remaining slides, okay? So look out on Teach Floor. I'll tell customer success when these are done. So at least we've covered all of our bases, okay? Raptor, you want me to do more? Shiraz, this will be done tomorrow, so it'll be on Teach Floor tomorrow as well, okay? For sure. Okay. We're not going to have time for a blue cat because I'm feeling pretty rough today. How does 24 over 20 make 6 over 5? Okay, you tell me. So if we divide that one by 4 and that one by 4, so 4 goes into 25 times 4 goes into 24 6 times, done. Okay. Here, yeah, absolutely. We didn't. I've just said that. We didn't have time to do it, so we will do those as an extra video, okay? So you're welcome. Right, we will leave it there. Hope we learnt something, and I will see you guys next week, okay? Thank you very much. You've got a terrible cold, no worries. Okay. You're welcome, Layla. Absolute pleasure, okay? You're interested in fractions but not videos. Apologies, they go hand in hand. Okay, so tomorrow, look out for Teach Floor. I'll make sure all the content that we haven't done, it will be done. Okay. Ta-ta, and catch you later. No, Shiraz, what are you talking about? You're welcome, Smira. Fantastic. Subscribed? Superb. Keep on subscribing. Keeps the channel alive. And catch you later, guys. Well done. Thank you.